at any time you want to stop, you can, but at the end or any time after, if there's any specifics on a valve or specifics on a manufacturer, I'd be absolutely happy to take it as in-depth as possible. But the training itself is going to be kind of a very 10,000 foot view, generic, not brand specific, more of a true concept of a valve. So we'll kick it off. I put a little bit of a handout. This is the only handout part. Just kind of wanted to briefly go through some standards, and not necessarily the standards themselves.
I was supposed to be at this hour, but I can't. Is it okay if I switch to the?
Absolutely, yeah. I think there's a 10, a 12, and a 2.
Yeah, I'm going to switch mine to 2. I guess.
Right on. They're all the same. So I just want to go on a few valve standards. We're not going to go into the standards themselves. We're not going to take down, but I wanted to stop on a few. So federal standards, when you're dealing with federal standards, that dictates, it's what you gravitate to. What's the first thing to focus on? If you're dealing with a standard, go to the largest thing that narrows it down, and then you just try to focus down on what you're after. But I'm going to stop a little bit on the MSS, Manufacturing Standardization Society. You'll see this a lot. It's just specific codes that valves follow. So you'll see MSS ST110 as an example. And the reason I bring that up is that's a very important thing to look for when you're looking at valve standards or valve takeoffs or valve anything. If you see an MSS standard, just focus on that. That helps us narrow down. So that's a third-party standard. So that's the biggest theme of this going over all these is it's third-party. It's not a manufacturer doesn't dictate a valve standard. They can create features and benefits. They can create a patent on a design. But as far as the valve standard goes, it's a true third-party. It involves manufacturers. But manufacturers, engineers, installers, anyone that has an opinion, they come together and say, if we can create a standard, that helps cut through a lot of red tape. You don't need to reinvent the wheel every time you present a valve. If it follows this standard, then we know that that 10-page booklet of standards and specifications and design features, we've got it covered. So really focus on that. Anytime you see a standard, especially in MSS, really focus on that. It helps you identify it and get almost to the exact valve you need. NSF, the National Sanitation Foundation, when we see that, we're mostly thinking potable water. So if someone, and I bring this up because a lot of times someone says, hey, I need an NSF valve. You're fairly safe to assume they're talking about potable water, but it's always good to ask. NSF 61 is a hot one you'll see, NSF 372. That's, again, third-party, laundry list of rules and procedures, brought down into one easy standard that, yeah, this is NSF 61, no problem at all. So we know that we've achieved a goal. So, and then ASME, API, ANSI, ITO, and then I'll stop on UL again. UL gets a lot of credit. That's another third-party organization. So it's a complete third party. They have no say. They have no concern whether you do pass or don't or sell a valve or don't. It's a third-party organization. I bring that up because sometimes, again, someone says, I need a UL valve for gas. Okay, that helps us. That gets us in the zone of where we're going. But UL itself has nothing to do with gas. It has nothing to do with performance. It's a complete laboratory third-party assessment where you say, I want you to test my valve, take this valve, send it in. We want to UL code or ASME 1633. You bring them the code. You bring them what you're trying to say it can do. They're a third-party organization that does that. And they'll come back and say, yes, the UL Underwriters Laboratory stamps this valve and it can do this. So it's important to know that UL itself holds no value. It's not a performance feature. It's not a code. It doesn't mean anything. It means that a manufacturer paid for UL to go. They brought in a specific 100-page code to test it to all these parameters and let us know you did it, and it's accepted across all manufacturers or installers, institutions as okay. That is we can trust that this valve performs to the levels they say. So I bring that up again. Third party. Manufacturers have nothing to do with UL other than sending their product to them, paying them a bunch of money, telling them what they want them to test it to, and then getting back a certified document saying they're allowed to put a UL stamp for that code. And that's especially when someone says, I need a UL valve, a gas valve, UL. There's a laundry list of codes. So make sure the specific ones. If you're saying gas, is it half pound? Is it 5 pounds? Is it 125 pounds? What are we testing? What specifically are you looking for? And FM is the same thing. Third party, also with fire protection. But again, just remember, these themselves have no value towards a valve. It's not specific to that. It just means that a valve has passed the test, so to say. And then CSA, formerly AGA, that's just kind of a Canadian equivalent of the same. But I bring those up because anytime you're dealing with standards, it's not just, hey, this ball valve broke, I need a new one, easy peasy. If we're adapting to an application, we're finding out a proper valve. Focus on the standard, start there, because if you get the perfect valve but it doesn't meet the standard, it might as well not exist. Then I'll quickly go through a few, just kind of common abbreviations, stopping on a few to really hit it home. SWP, steam working pressure. That's important because then it changes the media. You'll see valves, most valves dual rate. Well, a valve is inherently, most of the time, 600 pounds. You bring in the term steam, you just change the game. So always check for a steam rating as well. If you're dealing with steam, make sure a valve is steam rated. Some manufacturers do not certify their lead-free alloys to steam. Some manufacturers do. So that's very important to identify. If we're talking steam, make sure you find the steam rating, not just the valve rating. And then when we're talking about ratings, WOG. I got to hit home on this one because WOG was a valve standard for a long time. Is this a WOG valve? People say it's got to be a WOG valve. Water, oil, and gas. The MSS, the little third-party organization I chatted about a little bit ago, they said no more. We cannot have WOG be a nomenclature because there's a lot of misconception. WOG, water, oil, gas. People said that's a gas valve. I need a WOG valve because it's for gas. The gas has nothing to do with fuel, has nothing to do with petroleum, has nothing to do with diesel. It's the inherent state of gas. So it's just that oxygen, or I don't know the technical term, but it's not fuel gas. But for 60 years, it was ride or die. That's a WOG valve, so we're good to go. So MSS said no more. That's you cannot. That's not what we're certifying to. It's not illegal to put it on a valve. You'll still find them on valves. But CWP is the new nomenclature: cold working pressure. So we have extensive write-ups to say, well, they needed to be WOG. Well, here's why WOG doesn't exist. And here's a write-up saying that CWP is the exact same thing. CWP alleviated a lot of confusion. No one thought it was approved for water, potable water, no. Oil, fuel, no. Gas, fuel, no. So cold working pressure, pretty straightforward. What can this valve do at a specified temperature? Most of the time, what they call ambient or standard is 100 degrees. That's the baseline. So 600-pound cold working pressure. So 600 pounds at 100 degrees is the baseline. Now, when you change to steam, media, etc., it obviously changes the game. So I pause on that one because WOG comes up all the time. Got to be WOG, got to be WOG. Okay, and it's anyone, they're probably okay. Oh, it's worked for 60 years. Why did it change? Nothing really changed except for the confusion. Because at the end of the day, it's still most likely a bronze body, Teflon seated valve with standard or stainless trim. And it works just fine in a fuel application, but it didn't get that UL certification to guarantee that it follows the standards that most people need. So again, it's worked fine for me before. You're probably getting the same valve. It's just been tried and true and proven. And then the WOG just took out any confusion that all valves are good for gas.
So your UL rated valves are all certified for fuel gas?
Most of the time. That's probably 95% of when someone needs a UL valve, they're doing it. But the gas, the UL is the tester, but there's like, you'll see, I don't know if anyone is familiar with a true cut sheet of a gas valve. They'll be like ASME, BIXP, 1633, 1612, then like YX, ZZP. There's just a tremendous amount of different gases. So overall, yes, the UL is a good identifier to find out what gas valve it is, but that's not, again, it's not a fail state that it's approved for the exact specification you're looking for. So the answer is yes, the UL for at least the Nibco side, and most we do, but they all have a subsection of what actual gas they tested it to. And the biggest thing is with that, with UL, is they test it half pound, 5 pound, and 125 pound. So someone says, oh, it's a 600-pound valve. Of course, it's good for half-pound gas. Low pressure is much more difficult to seal a ball valve than high pressure because the ball is, I'm kind of spoiling a little bit of the fun, but the ball floats in the cavity itself. And when the media, the water, or the gas pushes on that ball valve, it mechanically pushes it into the seat. So the ball is pushed into that seat. So the higher the pressure, as long as it's within tolerance, the better the seal. Lower pressure, you're not quite getting that mechanical force pushed on that ball. So UL we would send a valve to UL and say, can you make sure this can handle a half pound of gas at a long time, a nice slow seal, and then they come back, and that's its own code. They stamp it, say yes it can, and send it back. So primarily, yes, UL is for gas ratings, but you'll find dozens of gas ratings that they may or may not apply to. So that's the biggest thing on that. And then it all boils down to our second slide is we just need to know exactly what we're looking for this valve to do. And then the rest of the terms we'll kind of go over. So I pause on those because they come up the most and they're the most referenced valve. When someone throws you, I need an NSF valve, I need a UL valve. So I wanted to identify what they may or may not be asking and then what questions we need to ask. All right. So purpose of a valve in a piping system. You can't just say this is a valve, this is valve, the term valve, and this is what valve does. Well, valves have a tremendous range of possibilities and procedures and capabilities. But if you're going to throw just a moniker on it, purpose of a valve is to control flow. So control or manipulate flow in some way. Now, and then we'll kind of identify what does that mean. So that's when a valve is in a pipeline or a line of any kind, there's a specific reason, and it's overall, its process and purpose is to control the flow in one way or the other. So, and when we're asking a valve, someone says, hey, I need a valve to solve my problem. So this is kind of this gets you about 95% of the way home. So what are the principal functions of a valve? So what do we mean by controlling the valve? We're either talking about starting and stopping, on, off. You need it to start the flow and stop the flow. Do you need it to regulate or throttle? You'll hear the term throttling or regulating or balancing is another way to do it. Are we trying to fine tune the flow? Are we trying to dial in the flow? Are we trying to take 20 pounds, turn it into roughly 5 pounds, etc.? Are we trying to prevent the reversal of flow? Are we trying to make it so that it goes this way, but it doesn't come back into our fresh drinking water systems? Or checking the flow? Or regulating or relieving. So relieving, so a relief valve. Are we looking to relieve the pressure to make sure for a safety procedure to drain at a certain point in time or control? So that's how we would break down more if we were able to get a few more sentences out of it. And then the most important thing is service consideration. So once we've identified what are you looking to do with this valve, now we need to ask the most important question. What's going through the valve? What's the pressure, temperature, and media? That's the most important 3 questions with the valve you could ever ask. What's the pressure, temperature, and media? How intense is it? So that narrows it down. This is a 3,000-pound gas transmission line. We're out. So now we know exactly where we're going. This is a potable water. It's for a residential house, just 60 pounds coming in. Okay. What's the temperature? Are we talking steam system, boiling system? Is it cryogenic? You know, sometimes people drop that negative 120-degree bomb right at the end. Well, that changes a few things. What's the type of media? Is it a liquid, a gas? What is it? I mean, especially if it's potable, especially if it's fuel. But at the end of the day, if we know these things, what's going through it, we can pretty much get you to home base. Now, on top of that, operating conditions. Where's it going to be? In a ceiling, outside, underground, behind a wall. What's the environment? Is it in a steam bath? Is it in a tropical environment? Is it in a freezing environment? I mean, these are extremely important things because while a valve can handle the media, sometimes it can't handle the environment. We need to augment that in some way. Frequency of operation. Is this valve going to sit for 25 years and if it doesn't open, God help us all? Or is this just your kitchen sink and you're going to do it 350 times a day? That's extremely important because the longer, the less frequently operated, the more, you know, we need to make sure a maintenance plan is in place. We need to make sure some procedures are going down. And if it's a high torque, high use, high velocity actuation system, we need to make sure we're focusing on that to make sure the packing and et cetera. So all of these help us dial in a fine tune. This stuff is going to help us make sure that valve lasts a long time so that we're not coming back. So you said this valve would work, and then they drop the bomb that it's been in a freezer the whole time. And then overall space. How much space do we have? Is there space considerations? Do we need to sacrifice a feature to make sure we can get it in a confined space, or do we need to augment it and make sure it can handle insulation, et cetera? So what we're going to talk about, we're going to talk about ball, butterfly, bronze and iron, or what's kind of grouped in as multi-turn. And then we'll briefly just kind of go over the discussion, conceptual terms of industrial fire protection. And then press is in there for a specific reason, just a few, not only to bring to light that a lot of valves are adapting to press, but more importantly to understand additional questions and focuses that we need to do when it is a press system. So kicking off with the ball valve. What is a ball valve? So ball valve is a quarter turn valve with a closing member and a rotating valve, so a ball. So it's almost as true as it says. There's a physical ball inside of the cavity that has a port, and it opens and closes. So this came into the market, I believe it's true, you never know if it's hearsay, in kind of the space race era in the 60s, and it was kind of, valves couldn't always be just one thing, on, off. It's either starting or it's stopping, long material, long stems. So all that came out as kind of a way to more manipulate a flow, create a little more compact design, and be able to change out some seats for various services a little easier than its previous predecessors of the gate valve. And then the biggest thing about it is this quarter turn operation. So they needed easy on, easy off access as opposed to the previous, what they call a multi-turn. So it did bring a lot of features, and we're going to talk about that. The ball valve gets the most kind of attention in this because it's probably the most manipulatable valve out there. So it gets a little more credit and time than its buddies there. So applications is pretty much across the board. You're going to find ball valves in the majority of applications, that all valves are what they say whenever piping is involved. So commercial, residential, industrial, isolation, blow off, airlines, med gas, cryo. I mean, you find ball valves, you find it pretty much anywhere piping is involved. So the features and the benefits. So the body is probably the biggest thing. Because the physical amount of material required was reduced so dramatically, they could get a little more creative with the alloys. Now, the most common are still going to be brass, bronze, lead-free bronzes, carbon, and stainless. But the ball valve, you can find it in Monel, Alloy 20, PVC, CPVC, plastics, high chem. So it kind of opened up the world to now start to make a valve to suit service as opposed to hope the service can handle a valve that's already existed. Then we're going to discuss the body types. They make them in 1-piece, 2-piece, and 3-piece designs. So we're going to hit on that, and this is where you kind of pick up the why. Why would somebody ask for that? Is there a reason, or is it just because it's worked for 60 years and they don't mind if it changes? So features, low pressure drop. So when we're looking at flow, the term you'll hear is full port or full flow. So that's when the line size and the ball and the port size are the same. Very low pressure drop when it comes to a ball valve. It's full port, full flow. So that your media, and once it's open, the ball kind of blocks your cavities there. So you're really not eliminating too much flow. So it's great for low pressure drop applications when flow is essential. It's a compact design. It's got a lower flow profile. It's got an ease of actuation, and it took away a lot of space installation requirements. And bubble tight shutoff. So another thing it achieved is an interesting fact about valves is there's a significant amount of valves that are actually allowed to leak. Now, you'll never have a valve that's allowed to just stream out. Oh no, that's a design feature. That's not the case at all. But a lot of the old valves and high, severe service, it's a metal to metal seat. Now, inherently, because you have metal going right into metal, it's very difficult to achieve a complete shutoff. So what they call it's called a bubble tight or bubble allowable leakage rate. It'll be just small bubbles over a small period of time. It's never a flow by any means. But ball valves, because we are energizing into a soft-seated material, we're taking a ball and we're pushing it into a soft seat. We're able to make that sealing surface a lot easier. It can conform to that ball, so we can get bubble tight or zero leakage or 100% isolation, whatever you want to call it. So bubble tight is a term you might hear. I need it to be bubble tight. You say, well, I thought all valves were designed to shut off media. Bubble tight is different because that's where gate valves and some butterfly valves, they're allowed to inherently leak. There's no way for them to perform their capabilities and not have any leakage whatsoever. It's versatile, low weight, ease of operation, handle operations, wide variety. So, and then another thing which a ball valve did kind of inherently is it created its own position indicator. Another great feature of a ball valve, it's very easy to identify if it's on or off. If a valve, they always say the valve or the handle identifies the flow path. If it's on, it's parallel with the pipe. If it's closed, it's perpendicular. So immediately, and especially in situations where it's essential to know if a valve is on or off, you're looking up in the ceiling. That's nice. It's a nice feature, kind of a built-in, just, you know, they call it a position indicator. So on this side, we've kind of talked about this, port sizes. So full port, 2-inch line, 2-inch port, 2-inch flow, absolutely no obstructions. That's called full port. Full flow and full port are fairly synonymous, but the true port size itself is the ball of the valve, or the flow path of the valve matches or exceeds the line size. So no obstructions, full flow, full port. Standard port or reduced port would mean that to either save space, money, or just a design to achieve a different body style, you're going to have a ball or a port that is 1 size to 2 sizes lower than your pipe size. So that's called a reduced port. And in residential and plumbing valves, they kind of default to full port. But when you're talking about a 3-inch or a 4-inch, or if you're getting into the trunnion world, taking down a 4-inch stainless steel ball to 3-inch stainless steel ball saves a tremendous amount of money and space. So it's not, if flow is not, it's got to be full flow, or we're not sending a cleaning device through the line that absolutely has to not be obstructed. Standard port is a pretty good option to save a little bit of money and you know, or space or design features. So that when you hear port, that's all you need is your line size is one thing, but what's the port? What's the flow path of the valve? Is it the same? Is it full or is it reduced? End connections, valves come in all end connections: press, thread, solder, socket weld, butt weld, flanged end. So seating materials. So when we talk about a seat, we're talking about the physical kind of, it's called a seat that the ball seats into or mates into to achieve the shut-off. Now, the seat's important because the seat is usually the weakest link in the system. So, but with a ball valve, it's also something that we can fairly easily swap out and change. So when we talk about a seat, it's most of the time it's Teflon. Teflon's a good default seat. It handles a wide variety of materials. It's great with fuels. It's great with a lot of applications. It's great with water. So Teflon seated valve is probably the default. If you just pick up a valve, the majority of the time it's going to be Teflon seated. And then you also hear I need reinforced Teflon, or sometimes they'll reinforce with glass, they'll reinforce with carbon, reinforce with graphite. So that's just making it a little bit stronger, gives it a little extra oomph for whatever it's working for. And then there's a laundry list of about 1,000 other seats that are available, but those are the very one-off. I'm dealing with some high toxic, high abrasive, high stuff. So the seat can be a wide variety, but when we're talking about that, we're talking about the thing that physically makes the ball and seals it off. And it hits whatever's going through that line, it gets attacked by it. So we got to make sure our seats are compatible with our media. So that's where the pressure temperature media comes in. We're going to verify that. And then because ball valves are so versatile and interchangeable, we can achieve a tremendous amount of temperature ranges. I mean, that's like a standard range, but we can go all the way down to cryogenic -300 if we need to. And then pressure ranges, most of the time it's going to be 0 to 2,000. But when we get into more industrial valve, we can easily achieve 5,000 pounds with a ball valve, 10,000 pounds in some cases, especially for like small, instrumentation valves, etc. So the temperature ranges get quite a bit, but you got to make sure you have the right combination to get there. So I mentioned trim. So when trim is the overall kind of grouping of what we talked about. What's your ball made out of? What's your stem made out of? And what's your seat made out of? Now, most of the time, especially in the Nibco world and the commercial and residential, we're either asking, do you want it standard trim, lead-free trim, or stainless steel trim? That's a vast majority of the trim codes that we're talking about. Now, if we get into the trunnions or the gas, I mean, then, or especially like the forge, small diameter gates, welded checks, then the trim, it's astronomical, the combinations. But that's all we're talking about. We've identified the body of the valve. When we're talking about the trim, what's going in? What's the guts? What's the combination of material inside of that valve? So that's when you said, what kind of trim? Or I need stainless trim. So we can do a bronze valve with stainless inside. So that's when someone's talking about the trim, it's inside of the ball itself. We've already identified the body. So we're gonna one piece, two piece, three piece design. Overall, they follow kind of the same rules. We've got a packing. So when we say adjustable packing, because the stem itself, it's to make it blowout proof. Blowout proof is a term you see as a feature, but it's required. A stem has to be fed through the body of the valve, and it's got a little lip down here that it cannot pass this cast. And unfortunately, the reason that comes about is before they would take a ball valve, slam in the ball, slam in the stem, hopefully lock it down and move on. And then that stem actually became a deer slug coming out of that thing. And if the valve malfunctioned or if the pressure got too high, the stem itself would actually be a projectile coming out. So we need to feed that stem through the body cavity, and it's mechanically impossible for that stem to come out of that seal. That's called a blowout proof stem. It cannot shoot out of the top. So, and then and to make that so, we've got to pack it in, because if the stem can get through, media can get through. So we've got extra seats or packing, which are just small versions of seats in there that we have to now screw down to keep that media from squirting out. And then we've got a body seal to kind of keep the packing safe, and then seat rings, end piece, and retainer. So we'll go into that in more detail, but ultimately a one piece, two piece, and three piece is generally the same construction. So one piece design. Oh, see, there we go. Why would someone want a one piece valve? So one piece valve is great for low leak, zero leak, elimination of leak paths. So all valves are inherently built to not leak. So you got to either trust or you don't. But on especially in chemical applications, high industrial, steam, higher pressures, this just eliminates yet another leak path. When we say a leak path, anywhere where something is joined, there's an opportunity for the media to leak out. If you thread something in, if you put in a stem, there's opportunity for leak path. And to get a ball in there, we got to drop it in and seal it shut. So that's considered a leak path. We've eliminated that. Now, what did we sacrifice? We sacrificed the ability to be full port. Because there's no opening to the body whatsoever, the only way to create that is to take a valve and drop in a ball that is normally double reduced, but we can do a reduced. We have to take a ball that's one size lower, drop it in after we get the stem in there, and then mechanically seal. So instead of having a retainer assembly that we can just screw on, we've got to drop it in there and then mechanically seal. So that's the sacrifice of a one-piece valve. You eliminate a leak path, but you eliminate a tremendous amount of opportunities to maintain, to service, and to have a full flow or full port situation. But in chemical situations where they're not running line full throttle, they're more worried about what's going on in it. It is a great option for that. So two-piece. Two-piece is the majority of the designs. It's a body assembly and what's called a retainer assembly. Now, why it's a great design is because we take a body, we can pop off this body, or at the manufacturing level, the retainer assembly is off. We can put any kind of ball. We can keep it full port. The seat goes in, ball goes in. Put another seat on and do that and screw it shut. So misconception on this is that this is for us out in the field after the fact to take on and off. That's not the case at all. When this is mechanically joined at the factory or at the manufacturer level, it's screwed in with such force that it almost physically welds the threading shut. So if you were to pop this body seal with a wrench, you would absolutely eliminate some threads. Some people can do it, and they're right. So then why on earth do you sell seat and seal kits for it then? Well, you'll see it on the next slide. Technically, you can maintain this valve, but with the term throwaway is a naughty word. But at the end of the day, if you're going to take out a two-piece, 1-inch ball valve, the kind of cost, labor savings, and just peace of mind and keeping your warranty intact is just replace the valve. Don't go try to break the body seal. Don't try to repack it yourself on a two-piece valve. So that's more for the manufacturing benefits of allowing full port, in and out, easy design, quick assembly, easy to cast, etc. You'll find this in every application: potable, HVAC, steam, gas, fire protection, and limited chemical. The chemical is going to go kind of bipolar. We'll see on the next slide. So three-piece design. So three-piece is an end connection, end piece, and center body section. So why would somebody want this? Now why would chemical either want to go bipolar on us and go unibody, one piece, or 3-piece. So this is the valve that you invest in out of the gate. This is the valve that you can change in the field. This is the valve that you can update and manipulate to your needings. It's extremely user-friendly and it's extremely easy to service. And after the initial installation, replacement is minimal. So the end pieces can stay in line. These 4 bolts are taken out. You slide out the body center section, and now you have complete access to the entire valve. So this is where we sell. This is why we sell seat and seal kits. This is why we sell replacement parts. Because if someone is in a high chemical application where a valve there's no magic valve on earth that just handles it for the perpetuity of time, and if maintenance time is important, 3-piece valve is a great initial investment, and you can service and maintain this valve. Potable services like it too, because you can maintain purity, you can go in, you can clean out the cavity. And so that's the serviceable valve. That's the investment valve. And then it's great for inline maintenance. And then that also, you'll find it in many applications. Primarily, you're going to find it in high abrasive, high attack, or potable services, and med gas. So med gas, I'll talk about real quick. Why the med gas? Why is it 99%? Is it going to be 3-piece with some long tubes at the end? Because you can safely, so when you're soldering in or brazing in a valve, that's a threat to the seat. So you're putting high heat on a soft material. So if you're brazing in, especially brazing, if you're soldering in, you got to make sure you're saving that soft material from melting or getting overheated. Now, in a med gas, you can't have those impurities. You can't have burned Teflon in a medical gas environment. So you take these end connections off. You have brazed tubing out here. You braze away, have at it, nothing you can hurt, because you've taken your center section and you've completely removed it. There's not a soft seat to be found. So that's why med gas, you'll find them 3-piece valves, is because you can braze away and then safely insert. You haven't distorted any of the chemical properties of that seat. So dead horse at this point on the ball valve, but it just gets a tremendous amount of credit. It's versatile and low pressure. And then the handle designs created, we've now created kind of a Frankenstein, whatever you need a valve to do, to lock it up, to throttle it out, chain wheel. So we can extend it very easily to get outside of insulation. So all those questions of where's it going to go and what does it need to do, sometimes we can take the exact same valve and turn it into a completely different process. So that's where ball valves are the biggest focus. Most modifications, most updates come to ball valves. So now recommended for throttling. So again, those that have sold some will say, well, why do you sell memory stops? Why do you sell a device that locks that valve into a throttle position? When we're talking about throttling, we're saying it's not fully on, it's not fully closed. It's being used to manipulate or balance the flow. So a ball valve is able to achieve that, and you're not going to inherently ruin it by doing it. But if that's the purpose of the valve, is to throttle, this isn't your valve, because that ball, when it's in full flow position, it's a fantastic leak path. When it's in a throttle position, it's a very difficult leak path. You've created a cave, and now whatever's going through that valve is subject to attack the body. So we're manipulating the flow to cavitate or swirl around or create its own path inside the body itself. So if you ever get a valve back that's pitted right here after a couple of years of service, it's ripped out here. But the majority of the time this is how that valve was used, because you manipulated that path to take a way that it shouldn't be taking, and it just annihilates it. But they can do it, and there's no inherent problem with throttling with it. But if that's the overall purpose of the valve, you're not going to get the lifespan you want out of it. And then another one to hit on, it's not good for a quick opening feature. Most ball valves are rated for steam. It's perfectly applied. But the biggest concern sometimes is that you have the ability to really open up a steam system at a much quicker pace than traditional steam systems we're used to. A nice easy in for a steam system. Now we're kind of trouble. There's a possibility to shock a system because you just sent full flow, full throttle. You're not easing it in. So when we say, well, quick open stuff, in the beginning you said quick open design, easy on, easy off. That's not always the best case scenario depending on your media. So that's a thing to talk about. If it's being used for steam service, you don't just want to crank that bad boy on and shock the system. All right, so now we're going to get to butterfly valves. So for 2-inch and below, ball valves came in. And the ball valves go up to, you know, in training well, but for a lower application, 4-inch and below primarily, they kind of took the gate valve and replaced it and really kind of made their name in the game. Butterfly also came about and kind of created a nice little balance as well. So the butterfly is also a quarter turn valve. So it's a 90 degree on, 90 degree off. So, you know, just open, close, open, close. Great for throttling. Most manufacturers default to a throttling capability. When you're talking about a butterfly valve, if you ever see it or someone sends it, I need a 10 position locking handle. This is what they mean. There's 10 selected positions for throttling capabilities that you can take that lever and you can leave it in. Why is it great for throttling? Because when we open and close a butterfly valve, we're not manipulating the flow. We're not sending it to a different part of the valve. We're not sending it to a cavity. We're just deflecting the flow or limiting the flow. Great for throttling. So butterfly valve came in. It's got a rigid body. It's a sturdy valve. It's a low profile valve. And the physical disc mates against the body. I mean, there's definitely a seal. You're not going to go iron to iron. But the seal itself is either molded, injection molded, vulcanized, or cartridge style. But the disc itself just mates right into the body seat. Very simple design. Achieves bubble type shutoff and a very low profile. So, a drawback or disadvantage out of the gate, though, you absolutely cannot achieve full flow with a butterfly valve. That's impossible. You can never pig a butterfly valve. You can never have an API 60 butterfly valve. So the disc itself will always remain inside the waterway. So that's the best. At best, that's the most limiting factor that will always be in the waterway. So keep that in mind. You can never have a full port. Now flow can be achieved because that's not really going to slow down that much flow, but you cannot get a full port. Most available materials, like the butterfly valve or ball valve, because we reduced the profile, it kind of expanded the availability. Primarily to cast iron, ductile iron, CPVC, or lead-free. That's just pay to play because a lot of it's inherently lead-free. Fire protection and high performance. And then when you get into like ABZ focuses all on butterfly valves. That's where the world's your oyster. If you need a Monel, high alloy, high purity, aluminum, I mean, they make some wild stuff. And they also, with the seats, we can pay to play and make it to your service. You've got a high FDA, got to be FDA purity, white Buna, food grade. That's where butterfly manufacturers. It's very easy to create your own Franken valve to get exactly what you need. So butterfly valve kind of came in and did what the ball valve did, only we can do it in much greater sizes now. Typical end connections are wafer, just mates right in between two flanges. Lug style, this isn't a true lug style, but this is a good example of a lug. It'll have its own lug, so it almost acts as its own flange. It's just got a lug, so you're lugging right in. You can do dead end service with that. You can terminate a line. And then grooved end and pressed end. And then there's double flange, et cetera. But this is where lug and wafer is a vast majority, and grooved is a vast majority of the end connections for these guys. So lug type is compatible with 125 and 150, flat face or raised face. And then we get into the higher materials, and ABZ will get into the 150, 300, 600, sometimes 900, et cetera, and double flange. Groove type, so that's you'll see a groove butterfly valve has a different kind of body construction. So the disc is contained in a sleeve. So you'll see how's a disc EPDM. It's kind of all sleeved in. So it's just a different. It's not quite this design. You see the disc almost has the same jacketing material as itself. And then wafer style. This one is just mostly going to be in like the 125. You can do a 300 wafer. They make 600 wafer, but the higher pressure lug style is kind of it takes over in that department. So on the discs, I'm not going to get too crazy on the disc. Outside of a term that comes up a lot, which is offset. So you might hear I need a double offset or a triple offset. So what we mean by that is we're gonna take the disc. So most of the time it's just a shaft and a disc, nice and aligned, easy on, easy off, straightforward. Now if we offset the disc and the shaft a little bit, we're going to manipulate the flow path to an ease for seating. So you'll find that in the high performance world. So high performance, what do we mean by high performance? It's a general term. Mostly it's performing with steam or higher pressures And what we're going to do is we're going to make it a unibody. So we're now not allowing this butterfly valve to go either way, because we are going to create a little seating niche on this. So you'll see inside what they call a retainer, or the body inside here, we're going to create a little groove or a niche so that we can manipulate the media to push on the disc in a different way. We're going to offset it so it forces it into the seat, gives us higher sealing capabilities. And then triple offset, we're not only going to offset the disc, we're going to offset the angle. So we're really driving it home. If you hear triple offset valve, most likely going into a facility of some kind with high pressure steam. So if it's a true steam application for a butterfly valve, at minimum look in the double offset. At primarily you should look in the triple offset. That's where you're going to see those. And then disc, you'll see if you ever price one out, it's a laundry list of options. What kind of disc you want? What kind of seat you want? So you can build it to whatever you need. So operating life provides maintenance-free cycles. So unlike some previous valves with a lot of mechanics to them, a lot of moving parts, a lot of areas to trap some debris. So a lot of valves have a maintenance cycle. You got to cycle it, you got to flush it, you got to get that out of there. Butterfly valves create kind of an opportunity that it's fairly maintenance-free. It can sit for quite a long time because it inherently cleans itself. So when it's opening and closing, there's not a lot of places for media to get trapped. You're not like a ball valve where you're physically grabbing the water or the steam and keeping it inside. A butterfly valve wipes itself clean. So you're really wiping away your seat. It's pushing off all the gunk that accumulated here, and now it's going to send it nicely down line. So there's not a lot of snags, or there's not a lot of things that can just come up on a valve and all of a sudden it's not working. That's very versatile. The body material, you've reduced a tremendous amount of weight. And when we're talking just butterfly valves, you can play in the 10, 12, 16, 30, 36. And when you're comparing it to a flanged end gate valve, absolutely, there's a little slide and you'll see, they've thrown out 40% of the cost of an iron gate valve, but the physical weight, I mean, we're talking hundreds and hundreds and hundreds of pound difference, and can be installed in any orientation. Because you're not creating a mechanic system where if you have this down, you're now having sediment and media, and everything is just going to collect and trap if you orientate that incorrectly. That's not possible with these. Whatever way you need a butterfly valve to go, it can go. All right, bronze and iron valves. So these are grouped in what we call multi-turn. So multi-turn check valves get thrown in there just because they needed a home, and that doesn't really apply to them. But multi-turn is pretty much just that. It takes multiple turns to operate these valves. So in this family is check valve, gate valve, globe valve. Available materials depending on which angle you're looking at it. Most of the time on the 2-inch and below, you're going to be looking at bronze or some brass for very, very light residential, and then carbon and stainless steel in the flanged end and the industrial and API worlds. So end connections, thread end, solder end, flanged end, but you can have socket weld. You can kind of get into those worlds as well. DCR, so they play in the potable arena as well. And then we'll talk about IBBM and OSY. So a gate valve, it's probably one of the oldest valves out there. It didn't look like this, but the concept was there. It's just a physical gate coming down to isolate the media. Now where it came about was hollowed out logs. They used to hollow out logs to transport water, cut a little niche in it, slam another piece of wood in there, wedge it in there. That's where the gate came about. So gate valve is just that, just a gate. Now the biggest thing about a gate, if you take away one thing from a gate, it is for absolute on and absolute off service. You absolutely cannot throttle a gate valve. If you throttle a gate valve or leave a gate valve in a partially open or closed position, the lifespan will be nil. It'll work for as long as you want it to, but the amount of abuse. So hopefully you hear this. And they'll say, well, this valve doesn't work. I mean, I can't deal with this in my house. Well, good. You're using that completely wrong. And that gate valve would have lasted a year. And then you'd have gone to turn it. And that's all you get because you distorted your stem so hard. So gate valve on and off. So it's fantastic for steam. It's fantastic for severe applications, higher pressure, higher temperature. but it is absolute on or absolute off position. No exceptions with the gate valve. So now, another key term to remember if you hear is union or bolted bonnet. So if you're going to maintain this valve, you're going to put it on a good schedule, keep a good maintenance schedule going for this gate valve. This is called a union bonnet. So the top works is here. The bonnet is a union assembly. So very easy to maintain. That stays in your line. You can clean it out, defoul it if there's something going on in there. Take this out, change out your disc, change out your parts, maintain, lubricate, whatever you need to do. Slide it right back in there and put it in. So when someone says a union bonnet, maintain this valve needs to last a lifetime. We get a lot of slurry through this line. I'm always cleaning it. Go for a union bonnet. Then bolted bonnet, mostly iron. The larger diameter stuff, and then there's also a screwed in or threaded bonnet, and that'd be this, and that'd be similar to the two-piece valve. That's kind of screwed in there and set in there for longevity. You can open this and maintain it. It's not as, don't ever do it, but it's only like if it's a screwed in bonnet, they mostly are setting this one and forgetting it. They'll operate it, but they're not looking to maintain. It's pretty clean, potable water. They're not looking to open this up unless they absolutely have to. That's where a screwed-in bonnet is a little better friend for you. So rising and non-rising and OS and Y. So another term, I need an NRS valve. I need a non-rising stem, or I need a rising stem, or I need an OS and Y valve. So what they're talking about on that is the physical stem itself. If the stem itself is a rising stem, well, let's start with non-rising. So why wouldn't all of them be non-rising? They're smaller, they're easier. So one of the biggest things about gate valve and why we pointed out how nice it is when a ball valve shows us which way it's going. It's a non-rising stem. That's the drawback. You have no idea if this valve is open or closed. Fire protection won't allow it. Critical building services, maintenance cycles. You have no idea if this is on or off. So, but what you do, if I don't care, it doesn't. I'll know because the water will be there or it won't. So then, good. You can save space. You can save materials. You can save mechanical. It's lower cost. Excellent. What a great solution. Well, I need to know if this valve is open or closed, so it's a rising stem. So it's very easy to tell if that valve is open. The stem is exposed, you can see the stem. So now I need an OS and Y rising stem. Okay, well, what's the difference? Well, on an OS and Y, so these you'll see, you can put indicators on top, just everything outside screw and yoke, everything is exposed. So the screw itself is what rises. Your hand wheel stays in the same position, but now your screw and your stem is exposed. Again, very easy to identify this valve is open, very easy to identify if this valve is closed. So those are big takeaways there. When someone says, can they use a non-rising? Well, why do you need to ask that? Because sometimes it's very important to have a visual indication or they have a post indicator, etc. So that's, if we throw someone an OS and Y or a rising and it doesn't matter because they don't have space requirements, that's fine. That's rarely going to come back. They'll just say, oh, okay. But if we all ask, if someone says I need an OS and Y valve, or they give me a part number that is a rising stem, I'll ask and say, well, we've only got non-rising. Will that work? Because there's no visual indication. I'll ask on that one. The other way, if they have one, it's just a little long. Nothing too bad is going to come of that. So the gate valve. So why is it still in existence? It just sounds like it's just getting beat up by butterflies and balls. So it's still great for high impact service or high temperature, for high pressure, and you can manipulate these valves. You can add features. You can do hot tapping. You can do bypasses. Easy for a chain wheel. So's a butterfly, but it still has a tremendous amount. It's easier to actuate. It's for a gear operator for critical service. So they're never going away. And an iron gate valve has a home forever. But it's these long services where all they had in the beginning was a gate valve. That's what we're saying, well, there might be a better way. But there's a lot of things that a gate valve does that you just can't replace. So they'll always be there. Great drawn off, great for full flow. The gate's completely removed from your system. Great, it's got metal, so you'll see metal to metal on both sides. Why is metal to metal a great solution? Because it can handle a tremendous amount of heat. It can handle a tremendous amount of pressure, not tremendous, obviously, within the parameters of the valve. But there's nothing soft. There's not a soft material in there getting beat up. And this will have an allowable leakage rate, but it's great for isolation. Now, you cannot throttle it. Now the metal to metal. So now, why now all of a sudden is it bad? Because inherently when you're slamming metal against metal, it's going to create, it's going to mold, it's going to bend, it's going to chip. So you are beating up. So for a high frequency operation, your metal to metal impacts will take a beating. Seating is not bubble tight, so that's the end solution to that stuff I've been saying all along. This inherently has to be allowed to bubble a few times because of the nooks and crannies and the abuse that it's taking. And at the end of the day, if you're just using it for on-off service and there's nothing too crazy about it, you're adding a lot of extra effort. And then when we say automate or actuate, that means something that automatically manipulates your valve, open or close. Very, very, very difficult to automate a multi-turn valve. That's a specialty that we don't deal with. We don't do it. Very difficult to automate to a ball valve, which is very similar to that, just a 90-degree. So check valves. So check valves will come in swing, center guided, and double door. There's obviously a few more, but these are primarily. Swing type is just that. It just has a little disc and swing that opens up, lets the media through, and then just gravity does its thing, closes it back down. It's mechanically blocked, so any reversible flow cannot get through that. Very simple design. That way, yes. That way, no. Vertical up, sure. Vertical down, no, because gravity can't do its thing. Your check's going to be flapping. You'll create turbulation. People say, well, my gauge is going crazy down here. Well, that's because this thing is spiraling out of control. So, and then center guided and dual disc. So for space-saving design, for larger diameters, there's a dual disc. Just has two little discs right here that are supported by a spring to help close. Guys, a thing, always having an obstruction. So you cannot achieve full flow, but it's a great design. Wait for design slips in. But the thing about this is it's a quick closure, they call it. So it slams going pretty quick. What can happen in that situation is what's called water hammer. So if you close water too quick, water's coming in, you shut it off, it's going to bounce off that check and then send itself right back down the line. And on larger diameter material, it can cause a tremendous amount of damage. So a solution to that would be a center guided. So these are called straightening vanes, so it helps with turbulence. But so you've got a full-blown disc in your waterway at all times. But the flow is separated. It's straightened. Turbulence is coming out, and then they call it a spring assist or a non-slam or a silent. There's a lot less chatter with these, but it eases the flow back to help eliminate water hammer. It's not going to eliminate, but it'll reduce is the better word. And then you can assist with the lever and weight. So they call it cracking pressure is a term that is how much pressure does it take to open up a valve, to crack a valve. So lever and weight is a way to kind of manipulate that. It's not a science. Balance valves do that, or automatic control valves, but it can help. Oh, I don't want it always. I mean, I think there's a little bit of media to get there. That's where a lever and weight's a good option. So not too much with this. The swing's got the best pressure drop because it opens up full flow, lets it in, stops. You can get UL, and that's on that side. UL for fire protection. They are specified. They are identified a little bit better. Metal to metal seats, just like the gate valve, can handle a little more severe service. And then center guided and double door checks may have significant pressure drop. They're not may, they will. I mean, you will have a lot of obstruction in your waterway, but if it's protecting a $10,000 pump, and that's the nature of the doing business, it's well worth the cost there. Hydraulic shock, that's the water hammer I talked about, and you must install the correct orientation. If you install it backwards, you have a wall, so it won't work, and that comes up more often than you'd like to believe. And there's no ball tight seating. There isn't allowable leakage because there is no physical seat, and it is designed to open and close at all times. All right, the glow valve. So glow valve comes in, so the gate valve is getting beat up by the ball, and so what's the glow valve for? So glow valve is used to regulate. So that's where we use our regulate. This is a throttling valve. This is what we use to regulate flow. So how do we achieve that? Well, the flow, the sealing surface is protected. As opposed to the gate being the first line of defense, just getting beat up directly and head on, you've got a glow valve now where the flow is being physically manipulated down to the cavity and vertically up. So the seat is taking it directly up. So that's why we can dial this in. The stem isn't getting torqued, we're not getting beat up, and it's coming head on, and we can do positive isolation, better for soft seating, throttling only. If you're using it for on-off, it'll be fine, but you're way overkilling it, and you're sacrificing your flow. So that's where the glow valve comes in. It's used in all applications. You'll see it a lot in oil and gas, and a little bit of chemical, and refining, a lot of refining. And connections for all these is anything you need, thread, socket, depending on the application. And then the rising stem, the connections and the are the same as the gate. So you can get a rising stem, you can get a non-rising stem, and you can maintain these a lot easier. You can kind of manipulate the seats. I won't go too much into this, but the good thing about a plug valve is if you're really dialing in, you can kind of manipulate them to change your plug, to change how the precision of the media or how it seals. So if it really gets elevated into what you're doing with the glow, you can kind of, like a butterfly, you can kind of start to pay to play a little bit. We don't see a tremendous amount of that in the refining world, you will, or chemical applications. You'll see them changing the plug on us. So great for throttling. You can do bubble tight because you're coming directly down on the media. You've got a soft seat, metal to metal, same concept as before. Flow, significant pressure drop. So if you look at that, you're absolutely sacrificing flow. There's no way to have a full flow glow valve. You've got a tremendous amount of blockage in that flow. But as I always say, if you're complaining about the flow of a glow valve, you're using it wrong, because the whole point is to manipulate the flow. So that's kind of a good indicator. Well, I turn this thing on and it's like it drained. Well, then go to a gate valve or a ball valve, because you're overkilling that. So we kind of talked about this when we talk about industrial. Industrial is obviously a sector, it's a segment. It's not, there's no industrial valve, but valves are tailored for industrial applications. You're going to see them in pure, either bronze on the lowest level, but mostly this is the carbon and stainless steel, flanged in, high pressures, high speeds. This is where the seats come in. You know, the difference of a butterfly valve in a commercial application to an industrial application is significantly different. So we just briefly touch on industrial. There's no line set of industrial valves, but there's valves suited for industrial application. Again, boils down to those 4 questions we ask: what's it doing? Where's it going? How hot? And where's it going to be? So that's where all of these valves that we just talked about on kind of all my demos, at least, were on a more residential, light commercial, light industrial. Just now we put them into a high performance, mostly true ANSI class 150, 300, etc. And then flanged in, not too much on this, just other than you're taking that same ball valve design, throwing it in a flanged end service. If we're talking high performance or petroleum, in 4-inch and above, we're talking flanged in. All right, so this one's quick. Fire protection valve. Again, it's not a magic valve, but it's a valve that has all that stuff I talked about in the very first. That's what this is. It's a tremendous amount of research, testing, and approvals going to fire protection valves. So fire protection valves are easily identified because A, they've got their own price sheet, they've got their own price books. They're usually red, or the handle is manipulated red. They'll have UL, they'll have all sorts of codes. But the good thing about fire protection valves is they kind of overkill it in a way. They're AWWA, they're an NSF for potable water, they're ULFM for fire applications. So sometimes fire protection valves get poached. If we need a potable water gate valve, sometimes we'll poach a fire protection one because it's got the approvals, it's got the thing. Don't ever send something into fire protection that shouldn't be in fire protection. It's not going to hold the approvals. It's not going to hold the standards. Yes, it might work. It might be the same valve, but on an inspected true fire protection system, it's not going to apply. It's not going to have the approval. So don't send things into fire protection that don't need to be. If you need to steal from it, you're usually okay. You're just overkilling it, or you're just taking it for some of its ratings. Features and benefits are that it's specifically tailored and approved for fire protection service. There's no specific feature I can sell on it other than it's designed for a fire protection service. So press valves, why do we bring them up? A lot of things are involved in the press on a residential, commercial, mechanical applications. I bring it up because it's good to think about, but the most important thing is always remember, if you're putting press ends on it, you can't Frankenstein a 300-pound glow valve to be pressed in and just think that it's going to maintain all of its capabilities. You're now sacrificing it down. to the weakest link. So there's a great question in Butte. He said, well, why is the FP 600 a 600-pound valve? And then now I pull these out of the box and they're 250 pounds. Because we need to rate it to the lowest level, to the weakest link. So press ends are usually rated between 250 to 300 pounds. You can't achieve your 600-pound rating on a press end. So I bring it up for two reasons. It's new, fancy, and exciting, but also always remember, you've now derated that valve down to a press system. It can't maintain its industrial properties because you threw a mail-in press adapter in there. So real quick, this is a nice visual representation on old systems, 100-year services, revamps, new builds. Why is the butterfly valve winning? 10-inch gate valve, 490 pounds. 10-inch butterfly valve, 55 pounds. Vertical installation requirements, 48 inches open. Vertical installations, 14 and a half. So, I mean, it's just one of those ones. If it's a competitive bid, if they're walking in with a new design, I mean, engineers most likely are already here. But if it's, oh man, this 80-year valve finally gave out on me, I need a new one. Well, you know, we got a ton of options out there. So that's where butterfly valves are coming in. And outside of needing those specific tapping or requirements, a butterfly valve, I mean, that's night and day. 490 versus 55 pounds. And the flow. So we throw the globe in here on the flow rate just to prove if someone's complaining about the flow rate of a globe valve, they're using it wrong. So poor globe valve just gets beat up. So this is the sacrifice you're having to throttle your line. And if you need to throttle, there's no question you're going to do it. But a butterfly valve versus a gate valve, you'll see. So for large diameters, they're pretty neck and neck. The separation does come. So you're saying, well, there you go. I'm not getting the flow I need. That's where the good questions come in. What's actually going through this line? Very rarely in a line do you have an application where they are running full throttle. They're running 600 pounds at 100 degrees and nothing will take nothing less. Very, very, very rarely. So we have good engineering. We can do mock diagrams, mock flow charts. We've got good pressure temperature. We can cut it off and prove that most people are hanging out in this zone anyway. So if there's a true concern about flow rates, let us know. Let your manufacturer of choice know. They can prove or they can either prove or disprove. Sometimes I'm like, wow, yeah, you absolutely are. I mean, good call. But most of the time it's gonna be like, well, this is your application. So and then on a 2-inch and below ball valve versus gate valve, same boat. So the globe valve again, poor guy, not having it. So gate valve versus ball valve on smaller diameter, very interchangeable, very limited flow sacrifice. So that's just when it comes down to it. And if there's ever a question on true flow, let us know. We've got charts, we've got write-ups, and we can either, and in some cases, like I said, we can help them say, you were absolutely right, just stick with that. Well, that's all I got.
Hold up, real quick. If you guys didn't sign this, can I get you to sign it? And then I need to take a picture for our yearbook and to prove to my boss we were really here. Thank you for that.
Well, thank you all for your time. If you have any specific questions, happy to answer any and all. So hopefully we've got some good tips.
Thank you guys very much.
To ask out there.
Lunch is coming sometime, but here too.
Sure, question for you.
Yeah.
So, contractor here in town is having trouble with stainless ball and stem 585s soldering.
Okay.
So he doesn't seem to have trouble with the standard S585s. The 80s don't stop. This is a lead-free.
Interesting. Because usually it's the
Other way.
lead-free. So the 585 80LFs, no trouble, but the 66 LFs is trouble?
Correct.
Interesting.
Yeah.
Because I know, we do solder training and stuff. I'm not aware of the stainless being the problem. Usually it's the low lead 585 lead-free bronze alloy that solderability is different or it requires ODH2O. But the stainless trim, I haven't heard it isolated to stainless on. Do you know what sizes? Probably 2 inches below.
Yeah. After 2. He
Interesting.
didn't say specifically which ones, but he put in 6 valves and 5 of them leaked.
At the joints?
Yeah, well, one of them was a packing issue.
Okay.
Tight pack, so.
Interesting.
But I don't know if he was getting it.
Well,
H2O.
yeah, I mean,
He did get some of the kitting plugs. But, normally they don't use that on their S585.
And like the F585/70 series doesn't require it, but all of the lead-free bronze does, either standard or stainless do. So I'm not discounting it all because it is a different solderability, but can they have comparison between the 80 trim and the stainless trim, or are they just happen to all use stainless in this
Well,
situation?
this job.
Okay. So maybe it would have been the same way. It's a solderability issue. We can leave our cards and we'll make sure we can send a form. We'll get those back and evaluate it. They'll tell us exactly what's going on with it. And the only thing I know is that, ODH2O flux, and it does require kind of a little, not different, but
More heat.
but the seats are okay. So long story short is we'll absolutely get those evaluated. I can't say a trick or to do on it, other than it might be a flux issue.
Well, he did say that it seemed like there was some oil coming out of the stainless, maybe some kind of lubricant. And he said it was pushing its way through the flux and the solder as he was trying to solder it, it was leaking pads.
Interesting.
So what he was doing is he was cleaning them up with alcohol to get rid of that. Okay. And then he was even trying tinning flux.
Interesting.
Which, we do have the tinning flux here.
Well, for both reasons, to make them whole, and I'd imagine we and Nibco would definitely want to take advantage of those.
I think he took them apart and cleaned them with the alcohol and then resoldered them into place.
Okay. Well, if that worked, that's awesome, but if not, I'm sure we'd want to take a look at those, so. But no, unfortunately, I don't have oh yeah, that happened. That one I'm not familiar with.
Do you have some kind of a valve soldering procedures, some kind of a chart?
We do. It's online.
I can get it.
Yeah, we'll grab an email. I'll send it to you. There's a video of one, and then there's also they call them a white paper. It's kind of step-by-step instructions on how to properly solder a lead-free Nibco 585 series.
Okay.
So absolutely, we'll get you with those resources.
Yeah, he said, if I'm doing something wrong on this, let me know, but.
The only thing that's really different is it does require more heat than the competition, but
He did say, as soon as it pulled the heat away, it seemed like it was just gone.
And then we've got kits we can send them too. If we're going to send them, hey, make sure you're following these. We'll send you a couple kits. It's a 3/4 inch or a 2 inch. It's a valve with you can take the retainer off, so you can pop in new seats, and it's got 10. So it's got one of these and 10 of these, and it's sold loose, so that we can unscrew it. It comes with 10 seat sets. We pop in a set of seats, put in a retainer assembly, and they can practice that as they're reading. So along with that material, we'll send at least 2 of those, so that you can take up to 20 attempts to make sure it's not a procedural issue.
and I'd be happy to come out with them and just beat up the questions or whatever.
Yeah. Well, yeah, those practice kits would be great.
Yeah.
Yeah, we can.
What I do is send them with them over to the union hall,
Yeah, absolutely. And then we also, as Nibco reps, we do those quite a bit. We just call them solder training, or we group it in with an end connection training. But we do solderability trainings all the time.
Okay.
So do you have a card? We'll grab it. He's got it, but I don't want to let it lie. But no, we'll get you all that, and then absolutely the next level is we'll put on a lunch and learn or after hours training for them and really hammer home. But sometimes just having those kits is nice. It might just be a technique refining situation, and those kits make it nice. You got 20 shots and dialing it in. So
right.
But yeah,
Yeah, absolutely.
Squeezing out of there when they eat it up. We need to find out what that is. I will, probably answer.
Lunch will be here at 12:15, so you guys that came, we'll have sandwiches up here.
Yeah, the thing.
Yeah.
From it, and so I told him.
Really? And that's what about the bare minimum is on it. I mean, you can put in an ultralight screen, but it almost turns it into just kind of.
Dave, that thing for short minute, it's half a pound.
No, I'm waiting to hear back from Mike on that.
It kind of creates it to just be like a big situation. But I mean, it'll have an ultralight spring in it. And no, but it gets very difficult to regulate anything at or below a half pound. Half pound is the standard crack pressure for 95%.
So basically what he has, they got a chemical injection pump, treating, they're reclaiming this mine of absorbent. And so they treat these.